Okay, so we have the question, the events A and B are such that the probability of A is 0.5, the probability of B is 0.2, and the probability of A given B is 0.4. So initially we are asked to calculate the probability of A intersect B. So A part I. Since we don't have the union of probability, the probability of the union of A and B, what we're going to have to do is we're going to have to link this conditional probability here to the intersect. And so we're going to use a conditional probability formula that the probability of A given B is equal to the probability of A intersect B all over the probability of B. Now this means when I rearrange that formula, we get the probability of A intersect B is going to be equal to the probability of B times the probability of A given B. So probability of A intersect B will be the probability of B, 0.2, times the probability of A intersect B, which is 0.4, and this gives us an answer of 0.08. Okay, so where do we get our marks on this question? Well, first of all, we are going to get one method mark for identifying the correct formula and its rearrangement in order to calculate the probability of A intersect B, and then we are going to get one accuracy mark for actually calculating that B, probability of A intersect B is 0.08. Okay, so let's have a look at part 2. Part 2 asks us to calculate the probability of B given A. So we can use the conditional probability formula again. Probability of B given A is the probability of B intersect A, which of course is the same as the probability of A intersect B. It doesn't matter actually the order there, same as within the union. This time though, it's over the probability of A. So what we get is 0.08 over the probability of A, which is 0.5. Remember, we can't leave this as a decimal. What we can do though is we can cancel this down as a fraction and write it as 4 over 25. I mean, this is a terminating decimal, which is 0.16, so it doesn't matter, it doesn't harm to write it like that. But remember, fractions are preferable to give exact answers. Okay, so how do I get my marks in this question? Well, first of all, we get a method mark simply for stating that we have the probability of B given A is probability of B intersect A over probability of A, and then we have an accuracy mark for actually finding out that the probability is 4 over 25 or 0.16. Okay, so part B. Giving a reason, state whether or not A and B are mutually exclusive. Now, if you remember, mutually exclusive events are events which cannot occur at the same time. Either one can happen or another can happen, and they're represented in a Venn diagram as something like this: two completely non-intersecting circles. So in other words, what this means is probability of A intersect B is equal to 0. Now, since probability of A intersect B is not only not equal to 0, but it's equal to 0.08, so it's greater than 0, then A and B are not. And please make sure you write a full sentence, make sure it makes sense as to why you have found they are not mutually exclusive. Okay, so this, when we look at how we get the marks for this, we get a mark for a statement that makes sense, that indicates that actually they're not mutually exclusive because of the existence of this A intersect B. Now that could actually be because there's a probability of A given B or a probability of B given A, since they both rely on A and set B actually existing as well. But the most direct way to say this is actually just to focus on the intersection and the fact that since it's greater than 0 and it exists, then they cannot be mutually exclusive because they're happening at the same time. Okay, I hope that all made sense.